Alright, so continuing on, now we're on the chapter 3 part. So when I'm trying to find the symmetry, I'm going to set this equal to y. So y equals negative 5 over x. And so when I graph this on my calculator, it looked like a curve going down this way and a curve going down this way. So the question was, what is the symmetry? So the first symmetry is the origin, which is this point, which means that xy can become negative x, negative y. So this point over here, which would be at negative, 5, negative 1, is over here at negative 5, 1. And so, yeah, we have things that are symmetric to the origin. If I take a flip over the x-axis, well, obviously there's nothing over here, so this one would be no, and the y-axis would also be no. When I tried to do it over the line y equals x, basically this point that I said was at 5, negative 1, now flips over to be at negative 1, 5. And there seems to be a point at negative 1, 5, because all we do is switch x and y. So the line y equals x gets a yes. So far we have 2, the origin, and y equals x. We also have to worry about the line y equals negative x, which goes that way. And so 5, negative 1 would then go to the point 1, negative 5, which is down over here. So the line y equals negative x is also yes. So we got 3 for that one. The next one simply asks what is an even function. And that is something that is symmetric to the y-axis. So if I have something going like this, I need something going like that. If I want an odd function, that's going to be symmetric to the origin, which means if I have something like this, then it has to have something like this. When we're looking for transformations, if I have y equals x minus 2 squared, the negative 2 inside the parentheses means we are going to go to the right by 2. And in 17b, if we have y equals the square root of x plus 6, the plus 6 on the outside means to go up 6. So that was 17. For 18, we have y equals, or actually we should say f of x equals x minus 3 squared plus 7. And when we want the inverse, the first thing we do is we switch the x and the y. How do we get rid of a plus 7? We subtract 7. How do we get rid of a squared? With the square root. Now remember, whenever you square root, you want to make sure you have a plus or minus in front of the square root. So that when I add 2 to both sides, we wind up with 2 plus or minus the square root of x minus 7. And since we're trying to find the inverse, that is the symbol for the inverse. Now, when doing this problem, we are going to be asked if this is a function or not. And this one is not because of the plus or minus, which means we get 2 answers. Alright, for problem number 19, it asks for us to graph y equals the absolute value of x plus 2. And so We got a point at 0, 2, and we can use our graphing calculator to make a V. And the point of the problem is not to be able to graph this, but to be able to graph the inverse. Because this first point is at 0, 2, the inverse will have a point at 2, 0. Since this is a point at 3, 1, we need a point at, I'm sorry, not 3, 1. This point is at 1, 3, so we need a point at 3, 1. And since this point is at negative 1, 3, we're going to need a point at 3, negative 1. And our V now is sideways. And we just graphed the absolute value of x plus 2 and its inverse. Alright, we're trying to find out if this is continuous or not continuous. And so what we're going to do is we're going to plug this in here and we're going to get 1. And if we plug this in here, we're going to get 2. Since these two numbers are not equal to each other, what we have here is a discontinuity that we can call a jump discontinuity. Remember, if we get 3 divided by 0, this would be an infinite. And if we got 0 over 0, we'd have to check our graph, but normally this is our point discontinuity. And these are for when we have a polynomial divided by a polynomial. And this right here is not, this is the piecewise. For 1 minus x cubed, we get a graph that looks snake-like, going like this. And it's not important to graph this accurately, it's important to know what happens. So, on the left side, when x goes to negative infinity, y is at the top of the graph up here, so y goes to infinity. Now, when x goes to infinity, which is on the right side of the graph, y goes to negative infinity, because on the right side the graph is at the bottom. We'll stop this one right here and pick it up with 22 on the next one.